we will look at generating random numbers. Random numbers in MatLab. Random numbers plays an important part in programming. And why might we need random numbers? For one, we can use random numbers to simulate statistical experiments. Okay, so computers can go through millions of cases. They can loop through one case at a time for millions of different cases. And each different case we can generate random numbers and repeat our experiments back and back and back. And we can come up with some statistical arguments based on those, that looping or that all of those millions of experiments. Okay, so that's one reason why we would want random numbers. A second reason is if we were programming a computer game where maybe we were simulating a deck of cards being shuffled, okay, and you get a card at random. We would need a random number generator there. Maybe we're simulating a game where you're rolling some dice, and you roll a 1 through 6 on each die. You might also be playing against a computer for something, maybe like a tic-tac-toe game, and it's not a very good strategy, but maybe the opponent, the computer, is playing marks at random. Okay, maybe that's the easy level on a tic-tac-toe opponent, is playing marks at random. Also, there are specialty applications where maybe you want to develop a program that generates a random password so that you can use for your email, to log into your email, for example. Okay, so these are just some cases. Now, MATLAB can help us with our random numbers, of course, and we're going to look at a couple built-in functions. Okay, going to look at rand n, rand I, and rand Perm. Okay, there are others in MATLAB, but these four are what I want to take a look at in this video. Okay, so I come over here and I'm in MATLAB, and I can type rand, and I'll hit enter. Okay, and it gives me an answer, 0.8147. I'm actually going to write that down. 0.8147. And I can type rand again, and I get another number. I'm going to write that one down, 0.9058. Okay, what rand is doing is generating a random number between 0 and 1, and it's a uniformly distributed random number. I don't want to get into probability theory in this video or in this course, but a uniformly generated random number, you can think of a graph like this, where this is flat right here, between 0 and 1. And the probability of getting a number between some interval, say between maybe 0.4 and 0.5, is equal to the probability of getting a number between, say, 0.5 and 0.6. So the probability is concentrated evenly or uniformly throughout 0 and 1. Okay, so I've got my random numbers there, and I'm going to type help rand, okay, to learn more about this function that I'm using. So I do that, and I scroll up, and it says, yep, uniformly distributed pseudo-random numbers. Now it turns out a computer cannot generate a pure random number. takes an infinite amount of computer memory to do that. And of course, that's not possible. However, computers can generate pseudo-random numbers in that their random numbers pass statistical tests for independence and for randomness. Okay? So for all intensive purposes, and for all our applications, we may assume that the numbers that we're getting are in fact random. Though as a computer scientist or an engineer, you should understand, or at least know, that the numbers that a computer generates cannot be purely random. Now we see here that this rand function will take one input. Okay, now up here when we called it, we didn't give it any inputs. And it says, oh yeah, there's that input n. It says it returns an n by n matrix containing pseudo-random values. Alright, so let's try that. I'll clear the command window. I'll clear the workspace. And let me say rand of 4, like that. And look at, I get a 4 by 4 matrix of random numbers taken on the interval from 0 to 1. And if I want to save that matrix as something, I need to say m equals rand 4. Okay, so I do that. I have a different random matrix now, of course, but I've saved that random matrix as m. So if I CLC, clear the command window, I can type m, and I have this random matrix now saved into memory. So that's the rand function there. Okay. Now, I wrote these numbers down. The first time I called rand, I got this number. The second time I called rand, I got this number. Believe it or not, if I were to exit MATLAB and then reload it, okay, open it back up, and type rand, I would get this number. And if I would type rand again, I would get this number. MATLAB has a way, and computer languages in general have a way of remembering what the random number was that was generated. Okay. The reason we want such a thing is that if we're performing a statistical experiment and we generate some random numbers, and whatever we're doing was interesting in some sense, maybe we want to repeat that exact same random experiment. There's a way to recover all of those random numbers that were generated the first time. MATLAB pulls its random numbers from what's called a random number generator, or RNG. And that itself is a separate function, RNG. And its input is what we call the seed of the random number generator. And it takes a number. Okay, so I'm just going to give it the number 1. I'm going to seed the random number generator. You can think of it as I'm planting an apple seed. Okay, and so the apple seed grows into a tree, and the tree limbs will be random. I'll have a tree limb here, and I'll have a tree limb here, and I'll have a tree limb here, but it's still going to be an apple tree. So I'm going to seed the random number generator, and now I'm going to call for a random number. And I got 0.4170. When I call for a random number, now the random number generator changes states, so that when I ask for a new random number, I get a different random number. Okay? But if I go back and I plant that apple seed, again, that apple seed meaning I put the same number into the random number generator. Okay, and I hit enter. Now I'm seeding it back to its state before I called any random numbers. Okay, I'm seeding it back to that apple tree. So now if I call for a random number, guess what I get? That same random number, and it changed states. But it changed states in such a way that the next random number I get matches this one over here. I can seed the random number generator with a different seed, maybe a watermelon seed, right? So I give it a 2 instead of a 1. So now that tree, that plant, grows and the limbs are randomized, but I don't have an apple anymore, I have a watermelon. So I seed it with a different seed. Now when I call a random number, I get a different random number than what I got up here. And if I call, and that changed the state of the random number generator, so now if I call another random number, I get an entirely different one. But guess what? If I plant that watermelon seed again, RNG of 2, and then I ask for a random number, look, I get this guy back again, that same watermelon plant, right, tree. And then if I ask for another random number, I get this guy back again. Alright, let me clear the command window, CLC. Let me clear the workspace. Also available to us is rand n. Okay, let's see what that does. So I'll just type rand n for right now, see what happens. Okay. Well, that doesn't seem too earth-shattering there. And then let me type that again. This time I got a negative number. So you see, this was RAND. This was the so-called probability distribution for rand. It gave me a number between 0 and 1, and every number was equally likely. So now I just got a negative number. That was not possible. That was not possible for this function. But for rand n, it is. Rand n, the n stands for normal. A normal probability is the famous bell curve distribution, where most of the probability is concentrated around here. This is -1 and this is 1. This is a normal. This is the standard normal. Okay, and this is centered at 0. So when I ask for rand n, it pulls random numbers out. Okay, but with a different distribution. So I get these numbers that are centered around 0, and most of the probability is concentrated between -1 and 1. However, other numbers outside of that range are possible. I wonder if we'll ever get one. There's one. There's one outside of that range. Okay, but it's just that it's not likely. You see. Okay. So again, I can seed the random number generator, RNG1. I seed it with an apple seed. Okay, and then I call rand n, and I get a random number. Okay, that changes the state of the random number generator, such that when I call it again, I get a different random number. But if I go back and I seed it with the apple seed again, RNG of 1, and I call rand n, okay, lo and behold, I get the same random number back. And it changes the state of the random number generator so that when I type it again, I get the same random number generated again. If I plant a watermelon seed, say 2, then I get an entirely different random number. Okay, and it doesn't have to be 2 or 1, it can be 5 or 10. I can plant whatever seed I want, 100. Okay. Good. So let me clear the command window there. All right. Actually, before we go to rand I, let me type help rand n and see all this information comes up. Rand n returns an n by n matrix containing pseudo-random values drawn from the standard normal distribution. But it does take an input n, so that means that if I type rand n 4, I get a 4 by 4 matrix of random numbers taken from the standard normal distribution. Also, if we would have read further, it can take two inputs. Say I want a matrix that's 10 by 2. So I've put rand n, its first input is 10, that's the number of rows. Its second input is 2, that's the number of columns. Hit enter. And there is a 10 by 2 matrix of numbers taken from a standard normal distribution. Of course, I can save it if I want. I can say m equals rand n 10 by 2. Okay. So now I have this matrix m stored into memory. That was from random number generation. Okay, let me clear the command window. Let me clear the workspace. Okay, for rand I, that's another random number generation here, and the I stands for integer. Okay, so if I need an integer, I would use rand I. Let me type help rand I. It says pseudo-random integers from a uniform discrete distribution, and it says that its first input is I max. Returns an n by n matrix containing pseudo-random integer values drawn from the distribution on 1 to I max. So that's jargon from saying I max is the maximum integer that you can get. So let me clear the command window, type rand I 6. Again, it returns 4. So what this did was it generated a random number between 1 and 6. Okay, and it gave me 4. If I do it again, okay, it might give me 3. If I wanted to repeat this experiment, let me seed the random number generator with something, maybe 50. Doesn't matter. And let me call rand I of 6. Okay, give me an integer between 1 and 6. Okay, 3. That changes the state of the random number generator. Give me another integer between 1 and 6. 2. Okay, now let me go back and seed the random number generator in the same manner with that 50. And now let me type rand I 6. And what is it going to give me? Yeah, 3. And that changes the state of the random number generator. And so if I ask for another one, what is it going to give me? Yep, 2. Just like up here. 3, 2. We seeded the random number generator with 50, then we called rand I, got 3, called it again, got 2. Then if we seed it back to 50, we get 3 and we get 2 again. Okay. Just like the previous functions, we can store a matrix. We can ask for a matrix. We'll say, give me a 4 by 4 matrix, or let's say a 10 by 2 matrix of integers between 1 and 10. So the maximum value is 10. Give me a 10 by 2 matrix, 10, comma, 2. And there's my 10 by 2 matrix whose maximum value is 10. Okay, and it's stored into memory. So there's M, and there it is. Okay, let me clear the command window, clear the workspace. Next on the list is rand perm. Okay, this can be useful for us in that it generates a random permutation of numbers between 1 and its input. So, for example, rand perm. If I type 10 here, it's going to return a vector of the numbers 1 through 10 permuted, okay, with a random permutation. So here's what it gave me: 4, 6, 7, 5, 2, 3, 10, 8, 1, 9. Okay, and I can store that. V equals rand perm 10. But it's going to give me a different vector now, because it's random. Each time I call it, it changes the state of the random number generator, okay, to give me a different random permutation. And it works the same way with the random number generator as the previous functions did. So if I seed the random number generator with, say, 1, and I call rand perm 10, okay, that gives me that permutation. And if I call it again, rand perm 10, it gives me a different permutation. But if I go back and I seed the random number generator the same way, RNG 1, okay, and then I ask for a random permutation, it gives me the same random permutation as I got up here. That changes the state of the random number generator, and so now if I ask for another rand perm of 10, it's going to give me this one here. Okay, and that changes the state of the random number generator, so that if I asked for another one, it would give me a third, possibly different random permutation of those numbers. Good. So I want to walk through 3 short examples using some random numbers. Okay. Let's go back here. All right. So let's go back to the rand function. The rand function, if you forgot, generates a random number between 0 and 1 on a uniform distribution. Well, that's all good, well and good, but what happens if I need a number, between 5 and 18? Okay, so let me write that down. Let's generate a random number. Actually, let's make it even more general here. Let's generate a random number between, we'll call a variable lower and upper bounds. Okay, in other words, I want to specify. I want to write a function that generates a random number. Okay, here's my black box. Between a lower bound, I'm just going to make a variable called lower, and an upper bound called upper. And it gives me one output. Let's call it y. Okay, it gives me y. And y is a random number generated between lower and upper. Okay, so let me create a new function. I'm going to come here to new function. Okay, I'm going to delete end. And in the function header, I'm going to input, or my outputs are y, just y. And I'm going to call this function rand, let's call it my rand, capital R. And the inputs then, we'll say, are lower and upper. Okay. And then I'm going to describe the function. Let's say my rand generates a random number on the uniform distribution between lower and upper. Okay, and I'll put my name there, Professor Kump. Okay, and I'll put the date. we go. Okay, now I want to use what's available to me to do this new function. Well, I know what's available to me is this function rand that generates a random number between 0 and 1. Okay, that's all well and good. And what happens if I were to multiply that number by, say, 10? That would be now a random number between 0 and 10. Yes, 0 and 10. So let's see what we get. 9.6826. 3.1342. Okay, so now I have an idea of how I can expand the range. Okay, from 0 to 1, I'm going to multiply by some number, and that's going to expand the range. Okay, so in my function, I might want to take rand times upper. Okay, we're going to store that as y, our output. Put a semicolon there. So that's now a random number that goes from 0 to whatever the upper input is. But what happens if I don't want my lower bound to be 0? What if I want to be able to change that? Okay. Well, if we think about it, if I take a random number and I add to it, say 5, okay, rand generates a number between 0 and 1. But if I add 5 to it, now this is a random number between 5 and 6. Right? So it's between 5 and 6 now. So if I come up here and I add to it lower, that is now, so if rand were 0, I would get lower, so that the bottom part of that range is lower. And if rand were 1, I would get upper plus lower as my largest number that I can get. Well, that's not exactly what I want. I want the largest number to be upper. So if I take this, and instead I subtract lower. Okay. Upper minus lower is actually the width. The width of the distribution. So I take a random number between 0 and 1, I multiply it by the width, and then I add to it lower. Now I've got a random number that should come from the distribution defined by lower and upper. Okay, so let me save that. I'm going to save it as my rand so that the name matches the function name. Save it. Okay. So clear everything. All right, so now let me generate a number. Let's say n equals my rand, and I want this random number to be between 20 and 100. Okay, let's see what it gave us. 75.3858. Pretty cool. All right, let's try again. Let's say, or let's do the same bounds between 20 and 100. Let's see what it gave us. 90.1111. All right, so it seems to be working. Let's get even stricter on the width and see if in fact this is working. Let's say I want a random number between 99 and 100. Okay, let me hit enter. Let's see what it gave us. 99.8946. So I'm pretty convinced now at this point that we've got the right number, we've got the right function. So let me just call it one more time. My rand 99 100. Let's see what we get. 99.0850. Perfect. Okay, and the last thing I want to add with this example is maybe I want random numbers and I don't want to repeat the experiment. I'm not interested in repeating the experiment. Every time I load this function, I want to get a different random number. I don't want to be able to predict it based on what I did last time. So if that's the case, if you're not interested in repeating your experiment, then you can type, before you call the random number, you can seed the random number generator with, instead of a number, you can type shuffle in single quotes there. And the single quote and the shuffle turn pink. Okay, and save that. And so now every time I load MATLAB and open MATLAB and call this function, I'm going to get a possibly different random number. So that's it. Good. Okay. Exit that, clear the command window. All right. Now I'd like to look at a second example. Okay, in this example, I'm going to write a function that takes no inputs, okay, but simulates the rolling of two 6-sided dice and outputs their faces sum. Okay. So you can imagine if I was simulating a game of craps, I'd have to roll 2 dice and I need to know what the sum is. Okay, this takes no inputs. Why would I need this to have any inputs at all? Okay, so here's my black box, and I'm going to call that function, and it's just going to give me the sum, s. Okay, so I'll come over here, and I will go to New, Function, and I will call this function 2 dice with a capital D. 2 dice sum with a capital S and D. Okay, the output is capital S, I'll choose, and the input is null. So I'll just delete that and just leave the 2 parentheses there. I'll delete end, I don't need it, and I will write the description here. Roll 2 dice and output the sum. Okay? Alright, so if I'm not interested in repeating the random number experiment, okay, I don't want to get the same thing every time I open MATLAB and I run it. So the first thing I'm going to do is shuffle the random number generator. Okay. That seeds it with an apple seed or a watermelon seed. The seed itself is random. Okay. Now if this is a 6-sided die, or 2 6-sided dice that we're rolling, okay, I can get 1, 2, 3, 4, 5, 6 on each die. So that's an integer and a maximum number of 6. So that's my rand I function, and I'm going to give it the input 6. Okay. Also, I want 2 of these guys. I want 2 random numbers between 1 and 6. So I'm just going to take care of both of them in the same command. I'm going to generate a vector, let's say a row vector, that's 1 by 2. And I'm going to save that row vector as maybe a variable called roll. Okay, you should be very descriptive in your variable names. Okay, let's see what this does down here in the command window before I proceed. I'll leave off the semicolon so we can see. See, my roll was 1, 2. And if I do it again, my roll was 6, 1. If I do it again, 3, 6. Okay, roll is a vector. It's got 2 elements. It's a 1 by 2 vector. Great. But what I'm interested in is not the roll. It's the sum of those two guys. So we're calling the sum capital S. So I'm going to say capital S equals, I want to take the first element of roll and add it to the second element of roll. So I'm going to type roll parenthesis 1 parenthesis plus roll parenthesis 2 parenthesis semicolon. So that computes the sum of the two faces. Okay, and I will save it. Save. And I'm going to save it with the same name as my function, 2DiceSum. Save, yes. Okay, I'll clear the command window, clear the workspace, and I will call my function. So I'll just say, let's call SS equals 2DiceSum. Okay, it requires no inputs. Oh, okay, the sum was 7. And if I call it again, oh, the sum was 9. If I call it again, the sum was 7. If I call it again, the sum was 7. 7 is actually the most probable number in this experiment. 6, 11. Okay, so it seems to be working. So I think you might start to see that, oh, this is using concepts from, and if you're following the sequence, this is using concepts from the previous video, 2 previous videos, 3 previous videos. Okay, that's the idea behind programming, is it just builds and builds and builds. Okay, it's like no other course in that sense. You know, you take a physics course and you know, you learn so much and it builds, but then there's like a release point, maybe a new chapter or a new section, and then it builds and builds and builds, and then there's a release point, maybe a new chapter. For example, you can understand electricity and magnetism even if you maybe didn't quite understand kinematics. Okay, programming's not like that. We just keep building, and there's no release point to this. And the third example I want to give is another comprehensive example. Okay. So for this example, I want to make a function that inputs a matrix and outputs, let me back up, a matrix of any size. Okay, so we're not going to make any assumptions on the size. Inputs a matrix of any size, outputs an element of the matrix chosen at random. Okay? Chosen at random. So our function, you know, our diagram will look like this. So we're going to input a matrix of any size, call it M, okay? And we're going to output an element of that matrix called lowercase m, okay, where this lowercase m is contained in this matrix or table, and it was selected at random. Gee, where's the built-in MATLAB function that chooses a random matrix element? Well, there is none. You have to use the tools that are given to you to figure out how to, you know, achieve or the certain task that's been presented to you. That's the beautiful thing with programming. It's a blank canvas. Here are your tools. Now paint me a picture. Okay, so I will go to New, Function, and I will call this function rand element, capital E, rand element, and it's going to output little m and it's going to input capital M. I'm going to delete the end of the function and describe the function. Rand element chooses an element of M at random. And I think I forgot last time, but I'm going to put my name. Okay, and the date. Okay. As is the case with most programs, there are many ways of doing this that give you the same result. All right. So first of all, if I have a matrix coming at me, capital M, and it can be of any size, it would make sense to me to randomly choose a row of the matrix and randomly choose a column of the matrix. And then so I take my random row, I take my random column, that gives me a random element in the table. That's what makes sense to me. Okay, well, the row is going to be a number between 1 and the number of rows, and it's an integer. So I'm going to need, if I'm going to generate a row, I'll call it variable row, I'm going to need a random number, and it's got to be an integer. So I'm going to use the rand I function. And I'm not interested in repeating this experiment, so I will shuffle the random number generator before this. Okay, so now I come back to my row, and I want a random number between 1 and the number of rows. Well, what's the number of rows? Well, we don't know, because M could be of any size. Now this comes back to the length function that we looked at a couple videos ago. I want to get the number of rows first. So I'm going to say n. So let me get the size of this guy. I'll say capital S equals SZ. We'll call it SZ equals size of M. Okay. So recall what that does. Let me generate a random number. Let me generate a matrix in the command window here. 1, 2, 3, 4. That's a bad example. 1, 2, 3, 3, 4, 5. Okay, there's my matrix. 1, 2, 3, 3, 4, 5. Now watch when I type size M. It says it gives me the number of rows, then it gives me the number of columns. And if I store that as something, S equals size M. Now S is a vector, and its first element is the number of rows in M, and its second element is the number of columns in M. So that's what I've got up here. So now when I generate a row, a random row, I'm going to say rand I, the maximum number that I want in this experiment, this random experiment, is whatever's contained in the first element of SZ. SZ is the size of M, and the first element is the number of rows. So the maximum number I want is the number of rows. So in other words, if M is a 4 by 3 matrix, this guy here, that's a 4. And so rand I will generate a number between 1 and 4. Okay, close that parenthesis there, and semicolon. Take a minute to savor that, right? Chew it up, savor it a little bit, think about it. Yep. We've made no assumptions on the number of rows in M. The first part of our program is to get the number of rows. Then, from the number of rows, we generate a random integer between 1 and the number of rows. Okay, and that will be our selected row. Similarly, let's make a variable called col, and column, our random column, has to be a number between 1 and the number of columns, and it has to be an integer. So again, I'm going to use rand I. Okay, and what am I going to put here? Yeah, I need the number of columns now, but that's the second element in SZ. So I'm going to type SZ2. And I'm going to be careful to close the two parentheses there. The first is for SZ, accessing the second element of SZ, and the second is to close the function rand I. Hit enter. Okay. So at this point in my code, I've shuffled the random number generator. I've got the size of M. I've generated a random row. I've generated a random column. Now I'm going to pick out that element of M that is at the selected row and the selected column. So we call that, in the function header, we call that little m. Little m is then capital M of row, comma, col, semicolon. Okay, I'll sprinkle some comments in here too. Shuffle the RNG, random row, random column, okay, and then this is our output. So I will save that. I'll save it as rand element. The name should always match. The file name should always match the function name. Save. All right, now let's play around with it. Clear the command window, clear the workspace. And I'll exit the editor. All right, let me generate a matrix. Let's say, let's use our random function to do that. Let's generate a 3x4 matrix. Generate a 3x4 matrix of integers no larger than 5. So there's our matrix. Okay. Now I'm going to choose, using our function, a random element of that matrix, and I'm going to say, we can call the output anything. Let's call it E for element equals, what we called it rand element, and then I give it the input M, and it says, oh, the element that I'm choosing out of this matrix is 2. Okay, and it works for any size M. Even a 1x1 it should. So let's say M is just 6. That's my matrix, 6. It's a 1x1 matrix. Now let's see what random element our code selects. 6, of course. Right? It doesn't really have a choice. Let's keep playing around with this. Let's choose a matrix. How about -10 pi 5 and 0. I need a comma here. Yeah, comma. Okay, so there's my matrix, and I'm going to select an element at random. That's selected 0. If we do it again, it selects 5. If we do it again, it selects 0. If we do it again, it selects 0. Pi, so forth. Let me clear the command window. Let me execute the code again. It selected 5. Remember, this is M. So let me open that back up, my random element here. If it selected 5, that means that row should be 2, right? And column should be 1. Now, if you remember from the previous video, functions keep their variables under the hood. We can't look at row and column because they're not in the workspace. But I can edit my function. I can leave off the semicolon for row and column just to see if it's working correctly. Okay, so again, here's my matrix M, and I will call it. I'll ask it to choose a random element. Okay, it chose pi. Here's E. E equals pi. And look what row was equal to. Row was 1 and column was 2. Yeah. Row 1, column 2. That's pi. Let's clear the command window. Let's try again. Here's M. E. I'll call my function. This time, it randomly chose 5. And the 5 is right here in M. This is row 2, column 1. So row 2, when we generated a random row, it generated 2, and column, it was 1 that was generated. Okay, I don't want to echo those things once I know that my code works, so I will put the semicolons back and call it a day. Okay. So let's look at the key points here. Key points. Okay, first of all, no matter what computer you have, it cannot generate random numbers. Pure, true random numbers. Computers cannot generate truly random numbers. It takes an infinite amount of computer memory to do that. However, computers can generate numbers that pass statistical tests of independence and randomness. So for all effective, intensive purposes, these numbers that we're seeing are in fact random. Okay? We can seed the random number generator, RNG. We put the seed there. It's a number. We can put whatever number we want there, and that initializes the state of the random number generator. And we would do this if we wanted to repeat our random experiment. If we're not interested in repeating our random experiment, if every time I boot up MATLAB and I play a game of craps that I wrote, I don't want to have the first outcome be the same every time I do that. So in this case, I would shuffle the random number generator. Okay, that means the seed itself is random. Okay, we looked at the built-in function rand, which generates a random number between 0 and 1 on the interval 0 and 1, and with equal probability. So the number can fall anywhere in this range, okay, with equal probability. We won't get into probability and statistics. We also looked at MATLAB's rand n function, which generates a random number in a bell curve centered at 0 with standard deviation 1. 1, -1. Okay, it's possible to get a number outside -1 and 1, okay, but it happens with very small probability. most of the numbers are concentrated between -1 and 1. We looked at rand I, which generates a random integer between between 1 and whatever number I specify as its input. So if I'm simulating a 6-sided die, I would put 6 as its input, and it would give me a random number between 1 and 6, an integer between 1 and 6. And we also looked at rand Perm, which gives a random permutation of the numbers from 1 to whatever its input is. If its input is 10, it might give, let's say, 8, 2, 1, 3, 9, 10, 4, 5, 7, 6, for example. Okay, a random permutation of the numbers up to and including 10. Finally, most important of all, we said that programming builds on itself. You're already starting to see now that this video used the key points from the previous 3 videos, and there is no letting up. Programming just keeps building and building and building